must first know where they are. In this video, you will learn how Ducks Unlimited Canada uses remote sensing to map wetlands across the Boreal. Ducks Unlimited Canada's wetland maps knit together and analyze remote sensing information to create large-scale, detailed pictures of boreal wetlands. The tools and techniques of remote sensing are becoming increasingly sophisticated and accessible, allowing information to be gathered quickly and in large quantities over vast areas. Wetland maps provide an invaluable tool to land managers who need to plan and anticipate wetland impacts from development or other landscape changes. Remote sensing is the science and art of gathering information about a place or object without being in direct contact with it. Remote sensing information is commonly gathered by overhead instruments, aboard planes, helicopters, and satellites. Remote sensing instruments can see wavelengths beyond those visible to the human eye. Some instruments measure the solar radiation reflected from the surface of an area or an object, giving us information about vegetation type and health. Other instruments emit their own energy and penetrate through tall vegetation and the forest canopy, revealing information about the moisture condition beneath the surface. One group of remote sensing instruments measure wavelengths in the visible and infrared portion of the electromagnetic spectrum. This is called optical remote sensing and is good for gathering information about vegetation type and health. For example, this is a true color composite image of a wetland complex taken by the Sentinel-2 satellite. A true color composite mixes the red, green, and blue bands detected by the sensor to create an image that is similar to what we see with the human eye. A false color composite is created by mixing bands both within and outside the range of what we can normally see. This image was created by mixing the near-infrared, shortwave infrared, and red bands. The different colors in this image highlight differences in vegetation type and density, as well as soil wetness. Another group of remote sensing instruments, called synthetic aperture radar, or SAR, emit and measure wavelengths in the microwave portion of the electromagnetic spectrum. At longer wavelengths, such as the L or P band, these instruments can travel through forest canopies and the ground surface and provide information about soil wetness and even permafrost. In this image, the two polarizations measured by the SAR instrument aboard the Sentinel-1 satellite are combined to highlight areas of flooding shown in the pink hues. In SAR imagery, the surface water appears dark as no energy is returned to the sensor, while flooded vegetation appear bright due to the energy being reflected first from the wet surface, then off the vegetation and back to the sensor. Light detection and ranging instruments, commonly called LiDAR, emit laser pulses and measure the time it takes for the pulse to return back to the sensor. LiDAR systems are extensively used aboard specialized aircrafts to measure topography. Topography can also be measured using multispectral or SAR instruments. This is an example of a digital surface model that provides a height measurement of the Earth's surface, including buildings and vegetation. Higher elevations or taller vegetation are shown in red, with lower elevations or vegetation in dark green. Remote sensing information from these various sources is pulled together and analyzed using both computer learning techniques and the knowledge of experts, including scientists, indigenous communities, government researchers, and industry partners. Ducks Unlimited Canada's wetland mapping methods use a technique called object-based image analysis. Object-based image analysis groups spectrally similar pixels into objects and assigns each object a land cover class based on collected field data. Research has shown object-based image analysis is an effective tool for mapping diverse ecosystems such as wetlands. Here, the left two images show true and false color satellite imagery. The third image shows objects created by grouping similar pixels, and the final image on the right gives an example of the completed wetland map. Gathering field data allows analysts to develop a greater understanding of the landscape beyond the satellite imagery. The field data is also used to train the computer model and validate the wetland information mapped to reflect what's actually on the ground. When analysts visit a field site, they collect information about what vegetation is present, the estimated height of trees and shrubs, and other key features like standing water, hummocky ground, recent fires, and landscape position. This information allows analysts to determine the type of wetlands based on the Canadian Wetland Classification System, or Ducks Unlimited Canada's Enhanced Wetland Classification Data Model. Wetland maps refine our understanding of wetland characteristics and provide an invaluable glimpse into how wetlands function and interact across the landscape. Ducks Unlimited Canada's wetland maps form the basis of other spatial tools for mapping, managing, and conserving other key features in the Boreal. Mapping plays a critical role in conservation. Understanding where boreal wetlands are found, along with useful, timely, and consistent information about their characteristics, is key to managing and protecting them.